Hello everyone, this is Vijetha, Associate Professor in the Department of ECA from MLR Institute of Technology. Today I would like to talk on filters from digital and linear integrated circuits. So these are the topics which I want to discuss here. What is a filter? What are the types of filter? Comparison between active and passive filters, and need to discuss about ideal and practical characteristics of a filter. So first, what is a filter? Filter is a frequency selective circuit that allows only a certain band of desired frequency component of an input signal to pass through and attenuates the signal of undesired frequency components. It is allowing a certain band of desired frequency and removes an unwanted frequency. It attenuates the undesired frequency. Now, there are basically two types of filters. One is analog filter and digital filter. Analog filters are classified as passive and active filters. In passive filters, we utilize only the resistive, inductor and capacitors in a passive filters. Whereas in active filters, we include an active elements like transistors also. An active element uses an op-amp in order to minimize the effect of loading on frequency characteristics of filters. We can use op-amp also in active filters, which helps to minimize the loading on frequency. Filters are widely used in communications, signal processing and in some electronic instruments. Application of filters includes suppression of power lines and reduction of very low or high frequency interference, and to reduce the noise effect and the bandwidth limitation and some spectral shapings. Coming to comparison between active and passive filters, there are some limitations of passive filters compared with the active filters, and there are some limitations of active filters comparing with the passive filters. We will check one by one. Coming to first, we will see limitations of passive filters over active filters. See, in passive filters we will be using only a RLC. So, practical inductor tends to deviate from the inductance realized, where we are using only, if we are using a inductor here, that practical inductor tends to deviate from the inductance realized, and there will be a power loss because of dissipation in resistor and inductive elements of a passive network. And Q factor is defined as omega L divided by RL. Since RL is equals to 0 for an ideal inductor, the quality factor will be equals to infinity. But in practical network, Q will not be infinity because RL cannot be 0. For most practical inductors, the total power dissipation tends to increase with the frequency, since Q does not increase linearly with the frequency. The magnetic coupling creates additional problems in the form of unwanted and stray fields, which are harmful for applications such as satellite instruments. At low frequencies, the control systems and analog computers, practical inductor of reasonable Q tends to become bulky and expensive. As we are using an inductor, the circuit becomes bulky and also expensive. The dissipative loss starts increasing when an inductor is miniaturized. If you want to reduce the size of an inductor, the dissipative losses starts increasing. The Q of low frequency inductor roughly proportional to the square of a scaling factor. So, the demand for space saving system requires network miniaturization. This becomes a forbidden problem when inductors are present in the circuit. The quartz crystal helps the designer to alternate of inductance at high frequency range. Coming to advantages of active filter over a passive filter. Active filters can be easily tuned and can be easily flexible to determine the gain and frequency adjustments. Then op-amp has a high input impedance, low output impedance. Hence, active filters using op-amp do not cause loading effect on the source and load. Therefore, cascading network does not need buffer amplifiers when we are going with the active filters. An active filter for a fixed frequency and variable frequency can be designed easily, and frequency adjustable can be obtained by varying a external voltage signal in a active filters. Coming to limitations of active filters over a passive filters. The high frequency response is limited by a gain bandwidth product, and a slew rate of a practical op amp leads to comparatively lower bandwidths than the desired bandwidth. And the design of active filters become costly for a high frequencies. And active filters requires dual polarity DC power supply, whereas passive filters does not require the dual polarity DC power supply. An active element is prone to process parameter variation. They are sensitive to a conditions like temperature. Hence, the performance of active filters deviates from an ideal response. Coming to a filter. Filter is a circuit that processes a signal based on a frequency dependency characteristics. The manner in which the filter varies with frequency is called its frequency response, and it is expressed in terms of transfer function, which is given as h of j omega, where omega is equals to 2 pi f, which is an angular frequency, which is expressed in terms of radians per second. A filter is a linear two-port network with a transfer function h of s is given as ratio of v naught of s by vi of s, where this can be given in terms of frequency response as h of j omega is equals to magnitude of h of j omega into e power j pi of omega, where h of j omega is a magnitude and pi of omega is a phase response. Types of filters. There are 4 different types of filters, which are low pass, high pass, band pass and band reject filter, which is we have another filter which is called as all pass filter also. We will see one by one, but here in this we will see the basic characteristics of low pass filter, that is ideal and practical characteristics of these 4 filters. The first one is low pass filter. The low pass filter allows only a low frequency signals to a certain break point, which is a cutoff frequency called as FH, to pass through it, while the remaining frequencies will be suppressed. That is from 0 to, see, if you can observe the ideal characteristics, from 0 to FH, this frequency band is going to be allowing to a filter, and above FH, the frequency band above FH is going to be a stop. This frequency response is drawn between the frequency and the gain of a filter. Coming to a practical characteristics, see, we do not stop at exactly FH, there will be some delay over here. This is called as a transition band. The range of frequencies from 0 to higher cutoff frequency FH is called as a pass band, and the range of frequency beyond FH is called as a stop band. That is, the frequency range from 0 to FH are called as a pass band, and above FH we will be calling it as a stop band. But in practical filters you will be having this transition band, as it is not exactly have a cutoff frequency, it takes some delay to reduce the gain. Coming to a high pass filter, here only the above certain breakpoint, that is above certain breakpoint FH, that is above the frequency of FH, are going to be a pass band, and below the FH will be calling it as a stop band. That is, here instead of FH we will be using a FL, that is lowest cutoff frequency. So from 0 to FL we will be calling it as a stop band, and from FL to FH is called as a pass band. This is ideal characteristics, and here we are talking about the practical characteristics. Here also from 0 to FL it does not allow any frequency. From FL it starts increasing, and at exactly FL it produces that is after some FL it produces a pass band. Till FH it is called as a stop band, and above FL is called as a pass band. That is, that frequency between 0 to FL are called as a stop band frequencies, and the frequency which are above the lowest cutoff frequency are called as a pass band frequencies. Here the frequency response will be considered between the frequency and gain of a filter for all the filters. Coming to a band pass filter, here this is said to be as a particular band of frequencies are called as a pass band, and remaining are called as a stop band, and this can be occurred by combining a high pass filter and low pass filter. That is, it allows only a specified range of frequency to pass through the filter. It has a two stop bands. It has a two stop bands, that is between 0 to FL is first stop band, and from FH to F it is called a second stop band. The bandwidth for this band pass filter is given as FH minus FL. This is an ideal characteristics of a band pass filter, and is a practical characteristics of an band pass filter. It allows the frequency between FL and FH. This 0 to FL is called as a stop band, and from FH to infinity is called as a stop band, and the bandwidth is given as FH minus FL. Only this particular frequency band is going to be transmitted through the filter. Next, coming to a band reject filter. Here this is exactly opposite to a band pass filter. Here you will be having a two band pass filter, two band pass frequencies, and one band of frequency is going to be stopped. And these are the ideal and practical characteristics of a band reject filter. And we can say that 0 to FL, the frequency between 0 to FL is called as a pass band, and from FL to FH is called as a stop band. Band width of a stop band is given as FH minus FL, but the pass band will be from 0 to FL, and FH to infinity is called as a pass band. Practically from 0 to FL it is called as a pass band, and from FH to F is called as a pass band, and this is called as a stop band. That is, only a certain frequency will be stopped. These are the ideal and practical characteristics of a band reject filters. Coming to summary, here we have discussed what is a filter, what is a filter, types of filter, and comparison of filters, that is comparison of active and passive filters, where passive filters will be using only RLC circuits, whereas in active filters you will be using an op amp. There are some advantages using an active filters, and there are some advantages of using a passive filters. Based on your applications, you need to choose either active or passive components. And types of filters, there is low pass filter, high pass filter, band stop filter, and band reject filters are discussed here with respect to ideal and practical characteristics. Thank you.